Each hour at a cell phone factory, quality control QC tests the durability of 4 randomly selected phones. If more than one fails, QC rejects the entire production for that hour. So we have here 4 phones like this. We have here, sorry, phone 1, phone 2, phone 3, and phone 4. Now, they found the durability of each phone. Okay, so they said now, if more than one fail, they test. If we have 0, 1 are fail, 1 are fail, 2, 3, and 4. So we have 0, 1, 2, 3, and 4. They told me now, if more than one fail, we will reject. So here, what is we have to find now? N, we have to find the probability, and we have to find the Q here. What is N? N is 4. Then, if in 1 hour, 95% of the phones made are acceptable. So here, the probability of acceptable or of success is 0.95. And when it is acceptable or success when the phones fail the test. So P here, it's being fail. This is the success. And the failure, it will be accept.
Teacher, but isn't the 95% the acceptable, like the ones that pass? Yeah, so our P should be 0.05.
Okay. I started Sarsanjiti. So here, 95 of the phones made are acceptable. So that's mean here the probability of failure is 0.95 and the probability of
teacher, how is the failure 0.95? Because phones made are acceptable, which means the success.
No, here they told me about the fails. Here the success here is the phone fails. And here the experiment was made to see if the phones are fails, what is the probability of at least or more than one will fail. So here 95 of the phones of the failure of the phones will be Q, which is 95%. Here, look here, what is the probability that QC rejects the hours phone production? When they are rejected when the phone fails. So the probability of the phone fails is 0.95.
So teacher, why do you say that if the phones made are acceptable?
Yes, I told you here they have the opposite. Sorry, Susan.
I said because they want us to find out P on our own.
Yeah, here, I told you, look, yeah, Rose. If more than one fail, QC reject. So when they are rejected, and they fail. Right. Now 95%, if in 1 hour, 95% of the phones made are acceptable. Acceptable for the failure. Yeah, this is 95% is the probability of fail.
Yes, teacher. I got you. Thank you so much.
Yeah, and the probability now, if of acceptable or of getting okay, 0.05. Now then, I have N, I have P, I have a Q. Now I want to find the probability. Oh, they told me if more than one fail. That's mean I didn't want to find the probability of one as an example, C1 from 4, PP, or Q, and I will continue. No. Here, if more than one fails, if you see this word like this, what is the probability that QC will reject? You will not use this probability, this formula. We will use the binomial expansion. The binomial expansion can help me. How? I will write it like this. I will say that the probability of pass plus the Q to the power 4, because here N is 4. And we said like, oh, we solved it yesterday. We say 1, 2, 3, 4, and 5. Then 0 from 4, 1 from 4, 2 from 4, 3 from 4, and 4 from 4. And then we have P. And then we have a Q. Sorry. Then we said here 4, 3, 2, 1, and then 1, 2, 3, and 4. Then so after we write the binomial expansion as we learned yesterday was where P plus Q to the power 4 is equal like this. Then here, see the combination 0 from 4 is 1 and 4 from 4 is also 1. The probability to the power 4 plus C 1 from 4 is 4 P cubic Q plus 6 P squared Q squared plus combination of 3 from 4 is also 4 P1 Q cubic plus 1 Q to the power 4. So after I wrote now the expansion of P plus Q to the power 4, after I wrote it, I will come now back to evaluate it here. Now P is 0.05 to the power 4 plus 4.05 cubic times 0.95 plus 6.05 squared times 0.95 squared plus 4.05 times 0.95 cubic plus 0.95 to the power 4. Now, these numbers here, as you see, 4 P plus Q for all of them, yani 4, 0, P of 0, plus P of 1 plus P of 2 plus P of 3 plus P of 4. These numbers here are, as I told you, the probability of 0, of 1, of 2, of 3, of 4. Now, yesterday when I told you what is the probability of exactly 3 from 4. 3 from 4, that's mean you will go to the third term and you will say that at this third term, will be the probability of 3 from 4. But here now, I told you if more than one fail. If more than one fail, that's mean I'm talking about probability of 2, of 3, and 4. I told you now, as I told you, we have 0. We have 0, 1, 2, 3, and 4. Now, if more than one fail, so which I'm talking about 2 and 3 and 4. So I need now to find the probability of 2 plus the probability of 3 plus the probability of 4. Okay? Here, why I need now the binomial expansion? The binomial I need it, I make it to help me to find the probability of 2 plus the probability of 3 plus the probability of 4. That's why I need the binomial expansion. Now, where's the probability of 4, 3, and 2? Where's the probability of 4?
So the first term.
Yeah, it is. This is the probability of 4. This is the probability of 3. And this is the probability of 2. Here, the probability of 0 is acceptable. That's mean 4 is failure. 1 is acceptable. That's mean 3 is failure. And 2 is acceptable. That's mean 2 is failure. So you will add this number plus this number plus this number to find the probability of 4, 3, or 2 phone fails. Let's find it now in the calculator here. Point 0, 6 or 0, 5 here. The 4 here. Plus we have point 0. Here we have 6 to the power 10 times 10 to the power negative 6. So 3, 4, 5, 6 plus here we have 0.05 cubic times
Teacher, I got it as 0.0140.
point. This 4.75 times 10 to the power negative 4. Okay, plus the last one here. This 0.01353. So when you add them, you will get the answer, which is 0.014. So I will repeat here. In this type of questions, when I told you what is the probability of at least 1 from 4, you will need to find first the binomial expansion. After you find the binomial expansion, you will see where is the probability of 0, where is the probability of 1, where is the probability of 2, and you will add them. I know this example, maybe it's hard. Now I will give you this one now here. It will be, inshallah, you will understand the binomial distribution. Here now, a multiple choice quiz has 5 questions. So here we have 5 questions. Question number 1, 2, 3, 4, and 5. Now each question has 4 answer choices. Each one here have 4 choices. So what is n?
5.
N is 5, the number of questions. Now, if you guess every answer, what is the probability that at least you're getting 3 correct? So now, here, they didn't tell me what is the probability that you get 3 from 5. They told me at least 3. So, when I told you at least 3, so I want the numbers that is greater than 3. Okay, probability that is n greater than 3. We have independent question or independent events.
At least greater than 3 or greater than or equal to 3.
Yeah, shouldn't it be equal also?
At least.
Like we can either get 3 or 4 or 5 correct.
Oh, yes. Thank you. So here now I have to say, so after I wrote these 2 things, n is 5, I need to find a probability of getting n at least 3. Now I will ask my question myself, is a binomial distribution or not? Let's see. We have a fixed number of trials. Yes. We have an independent events. Yes. If I asked the question, the first one correctly, that doesn't mean I will ask the second one wrongly. Each one is an independent event. The third one, do we have a fixed or a constant probability for each question, for each choice in each question? Also, yes.
Yes.
So I'm talking about binomial distribution. To find the binomial distribution, we need n, we need p, and we need q. Now let's come back now to the how many choices we have. Since we have here 5 or 4 choices, A, B, C, and D. So 4 choices. So each choice has 0.25. Why 0.25? Because I will divide 1 into 4 choices. If I have 6 choices, I will run 1 over 6. If I have only 2 choices, yani what did you prefer? You would prefer a quiz with 2 choices or 5 choices?
5.
You prefer 5?
For me,
I
yes.
prefer 2. Of course, 2, because the probability
Because
is higher.
Yeah, the probability of success will be 0.5. But if you have 5 questions, the probability of success is 0.2. So if the number of choices now are less or are smaller, so the probability of success will be greater. So here, a 1 over 4. So now the probability for each choice is 0.25. Now all of us know multiple choice question, that means one of them is correct. So what is the probability of success? 0.25. 25. And what is the probability that you didn't, or the answers are wrong? Will be 0.75. Is it clear?
Yeah.
Yeah.
Yeah, so
So 4
P is
choices.
0.25.
That means each choice has a probability of 0.25. And in the multiple choice question, only one answer is correct. So imagine that is A. So the probability of getting A is 0.25, but the probability of not getting A is 0.75. And both of them must, their P plus the Q must equal 1. So if I told you now we have 3 choices. Is the probability change?
Yeah, it should change.
Yeah, it will be 1/3.
1/3. So we have here 0.33, 0.33, and 0.33. So I found now P, Q, and N. Now let's go now to the binomial expansion. So P plus the Q to the power 5 is C 0 from 5, P to the power 5 plus C 1 from 5, P to the power 4, Q to the power 1 plus C 2 from 5, P to the power 3, Q to the power 2 plus C 3 from 5, P to the power 2, Q cubic plus C 4 from 5, P to the power 1, Q to the power 4, and C 5 from 5, Q to the power 5. Then let's continue here. 0 from 5, which is mean 1. 1 times 0.25 to the power 3 plus combination of 1 from 5 we have 5.25 to the power 4 times 0.75 plus 10.25 cubic 0.75 squared plus combination of 3 from 5 is also 10. 0.25 squared times 0.75 where I am now cubic plus C4 from 5 which is 5.95 times 0.05 to the power 4, and the last one here we have 1.75 to the power 5. So this is now, I found now by the binomial expansion, I found now P plus the Q to the power 5. Now, I didn't need all of them. I need the probability of at least 3. When I told you now the probability of at least 3, that's mean I need the probability of 3, and that's I answered 3 questions, the probability that I answered 4 questions correctly, and the probability of I answered 5 questions correctly.
Teacher,
Yes.
teacher, isn't it the last one plus 1 times 0.75?
Yes. Thank you. So here now, at least 3, that's mean the probability that I answered 3 questions correctly, plus the probability that I answered 4 correctly, and the probability of that answered 5 correctly. Now, you have to know here something, that when I solved like this in the binomial expansion, the first one here is for 5 correct. The second one of 4 correct. The third one here is for 3 correct. For 2 correct. 1 correct. And 0 correct. So the probability on of at least 3, that's mean 3 and 4 and 5. So that's mean this numbers plus this one plus this one. These are the probability that you answered 3 questions and 4 questions and 5 questions correctly. When you add them, you will get 0.1035 or 10.35%. Got it now? Is it clear? I think this is clearer than the previous one.
Yeah.
Yes.
Teacher,
Yes.
teacher, can you tell me again, like, how do I know if I'm going to use the combinations of how many ways and this one?
When I told you what is the probability of getting at least or at least 3, you will use the binomial expansion. But when I told you exactly 4 from 5, so I need only one probability, P of 4. Exactly 4, that's I need only one, P of 4. But at least 3, that means I need probability of 3 or 4 or 5. So to find these 3 probabilities, I will use the binomial expansion.
Okay, teacher, thank you.
Yeah. Now let's see this question here. Now they make a survey. They found that 80% eat corn on the cob in circles, like this boy here. This is 80% of people eat the corn cob, on the cup of in circles, and the others like from side to side. So 80% they eat it like a cup of circles, and 20% will be side from side. Assume that this sample accurately represents to the population. What is the probability out of 5 you know? Okay, at least 2 of them eat corn in other cup and circles. So
and here is 5, right?
yeah, so here now P N is 5. They told me now to find the probability of at least 2. That's mean probability of 2 plus 3 plus 4 plus 5. Now, that eat corn in a cup of circle. So what does it mean? Where is P? This is P. That they eat them in a cup of circle. This is P. So I want now to use the binomial expansion. So I will find now the binomial expansion as we know, which is C 0 from 5 P to the power 5 plus C 1 from 5 P to the power 4 Q to the power 1 plus C 2 from 5, p to the power 3, q to the power 2, plus 3 from 5, p to the power 4, q to the power 1, plus c, 4 from 5, p to the power 5, q, plus c, 5 from 5, p to the power, or q to the power 5. Now, as I told you, in the binomial expansion, this is for 5 correct, or you can say 5 are eating by a cup on circles. So I have to add p, 5 correct, and 4, and 3, and 2. So I will add these 4 answers, which is p of 5 plus p of 4 plus p of 3 plus p of 2, which is equal, I will see the answer here to find you the final answer. And number 25, it is 0.99328. That's it. This is the probability that at least 2 from the 5 are eating a circle and a cone in a circle.
Teacher,
Yes.
in the B, isn't it like 5, 4, then 3, then 2, then 1, not 4, then 5?
Here 5, 4, 3, 2, here 1, and here 0.
Because she wrote in the B.
Yeah, she made it by mistake.
Which
It's
one?
okay.
Um,
She means for probability of 2, you wrote P4 and Q1, but it should be like P to the power 2.
Oh, okay. And the cubic. Oh, okay. That's it.